Good morning, students. Today we will see the design of cyclic encoder. All of you know what is cyclic encoder. Cyclic encoder is the encoder built for n minus or n comma k cyclic code. The cyclic code satisfies linearity as well as cyclic property. So if a polynomial for generator is given, we should be able to design a encoder. In this encoder, we have n minus k number of resistors, and these resistors are connected with the help of switch S1 here through again other switches G1, G2 up to GQ minus 1, where Q represents n minus k value, and the message bits are first transmitted one by one serially, and after transmitting message bits, we will be transmitting parity bits or check bits by using the switch S2. The switch S1 is used to do the feedback connection during the transmission of message bits. So let us take an example. Before that, these are the steps we need to follow while designing an n comma k cyclic encoder. So the number of registers what we have to choose is n minus k, and we have to connect the registers based on the values of g in the generator polynomial. If the value of g is 1, feedback path is connected. If the value of g is 0, the feedback path is open, and the message bits are transmitted through switch S2, and it also is fed back to the register through switch S1. After k message bits are shifted out, we then have to remove or open switch S1 and then connect switch S2 to the check bits or the parity bits, and the parity bits are transmitted one after the other. So all the bits combinedly are forming the code word of cyclic encoder. So here we see an example where n is 7, k is 4. So q is given by n minus k, that is 3. So the highest power in the generator polynomial is 3, and the value of g1, g2 is shown as 1, 0, 0. So this path will be closed and this path will be opened. So we need not have this connection here. So let us see how it looks. It looks like this. Okay. So first we'll consider the message as 1100, and we need to apply in this order. The first bit is 1, and when we apply the message bit 1 here, simultaneously it is being transmitted to the output through switch S2, and this message N1 will be exclusively ORed with the output of resistor R2. You must be knowing that initially all the resistors will be reset to 0, and this exclusive OR output 1 is available here, and that is fed back through switch S1 to the inputs of the other resistors. R0 gets the 1 value here at input, and R1 gets exclusive OR of these two values as input. R2 gets the output of R1 as input to its value. And let us see after the application of the next clock cycle what happens. These are the values that will be stored in the registers. Next, the second bit has to be applied. So let us see what happens when the second bit is applied. So when the second bit 1 is applied here, and that will be exclusive OR with the output of resistor R2, and you get 1 here, and the fed back value will be 1 through switch S1, which is connected here. So this 1 acts as input to this register, and one exclusive OR with 1, that is 0, will be available as input to this one, and the output of this, that is 1, is available as input to this register. So these values get shifted when we apply the clock pulse, and the shifted values are seen here. So next we need to apply the third bit 0. So when you apply the third bit 0 here, that will be exclusive OR with the output of this register R2, and you get 1 here as the output of this exclusive OR gate, and that one is given as input to the register R0 through switch S1, and also to the input of this exclusive OR gate. And the input of this exclusive OR gate will be 1 and 1, and hence the output of this exclusive OR gate will be 0. So the output of this register will be 0, and that acts as input to this register. So these values get shifted to this registers when we apply the clock pulse. And let us see what happens. And this is how this is stored here. So the last bit next needs to be shifted. So it should be applied as input here. So when we apply the last bit 0, that is 4th bit, you get 0 exclusive OR with 0, and output here of exclusive OR gate is 0, and that is fed to the input through switch to the input of this register through switch S1, and to this register you have exclusive OR of 0 with 1 as input, and to this register you have 0 as the input. So let us see what happens at the application of the clock pulse. The new value 010 gets stored, and we have completed shifting all the 4 bits. So the remaining bits in the shift register are called check bits or the parity bits, and these bits now need to be connected to the output through switch S2, and these bits will be sent out one by one serially. So the complete transmitted word is 110 110 0 0 1 0. This is the complete code word, and the first 4 bits are due to the message, and the next 3 bits are due to the check bits or the parity bits. So all these bits will serially come out through switch S2, and when check bits are being transmitted, switch S1 on the top will be opened. This is how we can design a cyclic encoder. Thank you.